Welcome back to TAE Certification Training Series. So far in Chapter 4, we have covered 4.1 and Section 4.2. Today we will start Section 4.3, which is Test Automation Maintenance. Complexity of test automation solutions. Developing test automation solutions is not trivial. They need to be modular, scalable, understandable, reliable, and testable. The need for evolution. Test automation solutions, like any other software system, have to evolve, whether due to internal changes or changes in the environment in which they operate. And next we have importance and benefits of maintenance. Maintenance is an important aspect of architecting a TAS. Maintaining the TAS by adapting it to new types of systems to be tested, by accommodating support for new software environments, or by making it compliant to new laws and regulations, helps to ensure reliable and safe operation of the TAS. It also optimizes the lifespan and the performance of the TAS. So to summarize, TAs are complex systems that require ongoing maintenance to adapt to changes in the software and testing environment. This maintenance is essential for the continued effectiveness, reliability, and safety of the TAs and helps maximize its overall performance and longevity. Maintenance is done on an existing operational TAS and is triggered by modifications, migration, or retirement of the system. This process can be structured in the following categories. So the first one is preventive maintenance. Changes are made to make the TAS support more test types, test on multiple interfaces, test multiple versions of the SUT, or support test automation for a new SUT. So imagine you have a TAS that's working very well, but a new version of the software you are testing is about to be released. So to prevent any future issues, you decide to update the TAS to support testing on this version even before any problem arises. So that would be preventive maintenance. Next, we have corrective maintenance. Changes are made to correct failures of the TAS. The best way to maintain a TAS in operation, thus reducing the risk in using it, is through the execution of regular maintenance tests. Okay, so let's picture this scenario. Your TAS is running smoothly, but suddenly a test execution fails. So you investigate and discover that it's due to a compatibility issue with the latest software update. You then make the necessary changes to fix the problem and get everything back on track. Next, we have perfective maintenance. The TAS is optimized and non-functional issues are fixed. They can address the performance of the TAS, its usability, robustness, or reliability. Now, let's say your TAS has been running for a while, but you notice that it takes longer than you would like for tests to complete. So you decide to optimize it, making it faster and also revamping the user interface to make it more user-friendly. Next, we have adaptive maintenance. As new software systems are launched in the market, operating systems, database managers, web browsers, etc., it may be required that the TAS supports them. Also, it may be the case that the TAS needs to comply with new laws, regulations, or industry-specific requirements. In this case, changes are made to the TAS to make it adapt accordingly. Note: usually conformance to laws and regulations creates mandatory maintenance with specific rules, requirements, and sometimes auditing requirements. Also, as integrating tools are updated and new versions created, tool integration endpoints need to be maintained and kept functional. In this case, you have been using your TAS for a few years and new industry regulations have come into play. So in this case, then you have to modify the TAS to ensure that it complies with these new rules. It's like updating your car to meet new emission standards. You adapt it to stay legal and relevant. Maintenance is a process that can affect all layers and components of a TAS. The scope of it depends on the size and complexity of the TAS. So if it's really huge and complex, maintenance can be quite a task. The size of the change. So think about the changes you are making. If it's a massive change, the maintenance job will be more extensive. And the risk of the change. And finally, we cannot forget about the risk involved in the changes. If there is a lot at stake, like critical testing processes, you will have to be extra careful. Given the fact that maintenance refers to TAs in operation, an impact analysis is necessary to determine how the system may be affected by the changes. It's like doing a checkup to see how the changes might affect the system's health. Depending on the impact, the changes need to be introduced incrementally and tests need to be carried out after each step to ensure the continuous functioning of the TAs. It's a bit like renovating your house one room at a time so you can still live in it. And of course, after each step, you would want to run tests to make sure that the TAS is still working smoothly, just like testing the water and electricity after renovating a room in your house. Note, maintaining the TAS can be difficult if its specifications and documentation are outdated. So it's just like trying to repair your car without a manual. It's much harder. So keeping everything up to date is crucial for effective maintenance. We will wrap our today's session here. In our next session, we will continue with the scope and approach of test automation maintenance. Until then, happy testing.